Hello and welcome to Practicalli with me, John Stevenson. So we've been going through Clojure Spec, experimenting and learning along the way, and I've certainly learned a lot of things. Hopefully you have as well. It's quite a lot to take in, so I will use this episode to do a recap of what we've done so far. I've also put a lot of content onto the site as well, and I'm also a lot clearer in how I want to use Spec. And before we start, I think that's important to kind of grasp before you delve into Spec. There's no prescribed way of actually using it in terms of a particular workflow that you adopt. You're free to use it in whatever way that you actually want to. So it's not restrictive or constrictive in how you apply it. You can use as little or as much as you want. And to be honest, it's the same with unit tests as well. I mean, the amount of testing you do and where you test and what you test is a decision you make for kind of the applications, and it might not be the same on all applications as well. So with the sort of simple examples that we've done so far, I've done Spec for all of the functions. However, I probably only want to do the Spec on a larger project. I only want to do Spec for kind of the most important functions, and certainly when it comes to running tests and running like 1,000 checks on the functions, I'm only really going to do that on certain functions at certain times as well. And a lot of some of the things that we've covered as well, I'm only actually going to be using during development time. It is a very useful tool. Even if you don't use Spec in production, it's a very useful tool to help you verify the designs you're doing and verify that things are still working without kind of adding a huge burden of having this kind of like huge upfront design of a type system. So you've got the flexibility to be able to do type checking, but in a very flexible and pragmatic way as well. So you're not tied to creating any hierarchies. There's a strong encouragement to use to continue using it's like a composite data structures. So having things like flat maps, so you would have a flat schema, a flat spec instead of a hierarchical spec as well. And so you can build up all these individual specifications and then combine them together, but they're not hard coded together. They're not forced into a particular hierarchy, so that they're very easy to change and very easy to create multiple different versions. We've seen where we had a card game that had different suits for the cards depending on the region that you're actually working in, but you can have a general playing card that has a suit, has a rank. Just the implementation of those can be different, but as long as there's one region, as long as you're satisfying one region of the suit that for those playing cards, then you can you're validated against the specification, and you are good data, because you know that even though you could have a few options, you can actually just use one of those options and use that with safety. So I guess what I'm saying really is that, so you take Spec as much or as little as you want, you use it how you want, and hopefully I've given you some ideas in how to do that, and hopefully this video will also kind of give you an insight into how I'm planning to use Spec in future projects. Okay, just before we get into that, let's see if my broadcast is working. There we go. So the website, I've updated the website a little bit. I'm doing the Clojure Together sponsorships, so I've done some project updates as well, so you can see what I've been doing on the books if you want a summary, or you can just have a look at the books. And I've also added a link to the Spec generative testing playlist I've got. So this will be the 5th video on this subject. And I think we'll actually just take a break from this from now. There's still a lot of work to look into about generators and writing your own generators and writing custom generators. And I just came across a library that does a lot of that work for you. So I'll cover that before we go. And then I've added just some activity buttons so you can see how active these projects are around the books, especially like how many commits I've done, how many content ideas I've got, and feel free to click on any of these if you want. If you've got an idea about what you want to see in the books, then feel free to add a new issue. It's a nice, quick, simple way to contribute back to the books as well. If you want to reach out to me, I'm on Practicalli, on the Clojure in Slack, or pretty much quite a few other channels as well. And there's ways to support me and keep me motivated. Hopefully you can understand me okay, because I've still got a little bit of flu. And I did stay up too late last night working on this book. But let's get on. So in the Practicalli Clojure book, which is linked off from the website, I've been working on a section with spec projects, and I fleshed this out a little bit more. Spec overview. I fleshed it out a little bit more. We talked about organizing specifications, so I'm kind of like settled with putting the specifications. If it's a reasonably small project, then just sticking them all into a particular specifications file under source, because you're going to be using that with as you're developing the other aspects of your source code. It's quite useful. So I put in there the spec definitions. So for testing the data aspects of my application, so all the data structures, all the values I'm actually using, so I have specifications for those. And then any predicate functions I'm actually writing as well, put those into the specifications file. And the function specifications, so the spec'd function definitions that we've done. And also I'm kind of, for small to medium sized projects, just putting any instrumentation and any calls to spec test check, because those are only pretty much one-liners. The instrumenting functions, again, we can have a little helper function for those, and we can do the same thing for test check as well. And then also there's the how often to actually run the generative testing, because if we call spec check, it's going to generate 1,000 data values, which is going to take I think on my computer it's taking like a minute or like 80 seconds to do one spec test check function on deal cards, which is fairly small. So it's kind of does take a little bit of time, noticeable amount of time to run. So in order to kind of preserve the fast feedback nature of developing in Clojure, then defining the spec checks with this optional kind of setting of the numbers of tests. So somewhere between 10 and 100 seems to be pretty good. They still run, like 10 tests run really, really fast. And it gives me like a fairly interesting amount of useful tests to apply to a particular function. And it doesn't interrupt that kind of fast feedback in there as well. And I haven't actually integrated those like test check into unit testing, but there is a def spec that you can use that as well. So I'm going to have a look into that in a little bit more detail. But essentially you can actually just use things like validate inside the unit testing, and I'll show an example of that later on as well. So you can kind of combine, again, you can pick and choose how much integration you want between your generative testing and your unit testing. You might want to keep them separate, or you might want to have unit tests and just have the like a metadata tag on there that kind of says, well, these are integration tests, so I'm only going to run those when I want to run kind of like full system integration, and I expect that to take several minutes, or hopefully not an hour, and that way I can kind of go and do something else, take a break while those are running, and come back and see what's happened when they've finished. Okay, feel free to ask questions as we go along, especially if there's something you don't quite understand or I'm not explaining clearly. So we've covered data. I'm not going to go into this in any details. We've covered data. So this is kind of like the fundamental building blocks of your specifications. You start defining specifications for various pieces of data, various pieces of information in your system. And we can use predicates, literal values, and entity maps. I added this description last time, but we've kind of used entity maps as well. So we've got a player account, and a player account is made of several specifications that are required, and there is you can also have some specifications that are optional. And that's quite nice, because you can pass information in around Clojure using hash maps. It's a very common approach because it's very flexible. Because functions can take whatever keys that they actually want from a hash map. So they might not want all of it. So they might not use all of those keys, but they can kind of they're not going to fail when you call them if you pass too many keys. But here we can specify which keys are actually required, so that we can ensure that we're passing the minimum amount of information. But if we provide extra information, then we can still call the function, but we're also checking that that extra function is valid too. So we're checking, so like, are the games played? Are they actually one of the games that actually we have? Is it a valid kind of piece of information that we're passing in? So even though it's optional, we're still actually checking it. So if we send additional information in there we shouldn't have sent, then we can catch that with the specification as well. I've kind of shown the difference between composite and hierarchical specifications. And again, this ties up to the design you actually have with Clojure itself. So do you take a more hierarchical, kind of nested data structure approach, or do you try and keep your data structures as flat as possible? And especially when we were doing, if you remember back to the data science stuff we were doing with COVID-19 and visualizing things with Oz, we had very large maps, but they were essentially, instead of having one big large map, we actually had one map that was kind of like a collection of very simple maps, very flat maps. So we actually converted the data to be just a very, each map was its kind of own self-contained piece of information. We didn't need anything else outside of that map to work on it. So it makes it very easy to process those the flat hierarchy maps very, very quickly and very easily with Clojure as well. And then we covered spec functions and oops, where are we going? And testing specifications. There's a little bit more to add on to that, and I'll cover some of that in a moment when we look at the projects and the generative testing. We're going to add some stuff here about using like creating your own generators, and there's a lot of kind of information I've just found the last couple of days about writing your own generators, which is quite useful. I did bump into that as we go through the bank account. I'll show you where I bumped into having to create my own data structure in there. So there's a card game that just basically covers kind of like some of the basics, covers writing specifications, generating data, doing functional specifications, and then doing some instrumentation. So there's no kind of like overall test check for this. But I have done this with the bank account. So this is taking a simple bank account project, and we're using a test-driven development approach. So we're writing failing tests and writing specs. So we've covered this a little bit, but I've expanded a lot more on the details. So this is a kind of a walkthrough on how to do this. So I've got this so you can create a new project, and then I've done kind of customer details, but I'm going to add the rest of the data specifications that we're going to work with. And I've done the registered account, and I'm going to add all the extra functions in here for the basic application. And then we'll instrument all these as well as we go along. And then once we've instrumented everything, we'll kind of take a look at the design and see which ones we actually really need to, which functions we actually really need to specify, and which functions we need to check, see if there are functions that are more important to do so than others. Excuse me. And so this is kind of the development workflow we're taking. So we're writing a failing test, writing a mock test, and in order to get the write some mock data, then write a function that returns the argument. So we need a function shell to actually be able to do that in order to get the function to run, get the test function to run. It can't run if it can't call the function. It's just going to fail. So we just put an empty, kind of almost an empty function in there. Let's show an example. There we go. So it is kind of put in an empty function in there to start with, and all we're doing is just returning. So it takes customer details, and we're just returning customer details there. So this is a map that we're taking in, and we're just returning a map. Anyway, that is what we're going to do. That is going to be the input and output to this function anyway. So that kind of makes sense, and it's often a common approach is you design a function to take in a map value, especially if there's lots of details to process, and then you just return the processed map as the result. Then we run the tests. Then I've written some specifications. Then you started using the specifications for the mock data, and then we start updating the functions, and then run any specification checks we want, and then we go back to the start again. So this is kind of the workflow I'm kind of working on during this project, and how we're kind of walking through here as well. So let's have a look at this. Writing a failing test. Again, we can still use the normal def test. Here I'm just using pretty standard kind of def test functions, just using is or as. And yeah, there's nothing different to this in terms of how you normally write unit tests. But later on we'll kind of update this so it's actually using the specification to make it easier, because doing things like this, doing like set keys on the register holder. So we're calling register account holder with some, here we just have some mock data, just an empty map, which will still is a valid call. It just will return an empty map. And then we're expecting this to be kind of like returning some data like this. So it's basically adding the account ID. However, the way we're checking this is just feels a little bit clunky, a little bit too low level. We're testing what the data structure is rather than what the kind of the meaning of that data is. So it seems to be quite a low level unit test this. So probably more brittle in the long run. So we can see that later on we'll see that we can change this to use a spec, and it will be a more meaningful test and also a lot less brittle to change. And so we can add, again, we can add mock data to the to the unit tests that we're using. And so if we put these in defs, then we can use that mock data throughout all our tests. And then it makes it quite easy just to update that. But then the decision is, well, what mock data do you actually use? And this isn't changing. So we're not kind of widening the scope of what we're testing each time that we're testing something. So again, you could use specs to generate this mock data for us, and that way it would generate a range of data for us. So we'll migrate these unit tests to do that as well. Excuse me. So I've written a failing test, and yeah, I've already kind of highlighted that there is some improvements we could just make to even just a failing test before we've even kind of like got the actual function to work, and that will help us set up kind of writing nicer tests as we go through the development of the application. So we've covered some of this already, I think. So I'm not going to go through too much detail, but basically we're using Clojure Spec Alpha to write some tests, to write some specs. And all the spec names are these fully qualified keywords that we're using. So these will resolve into this namespace. So these will all be, their full names will be Practicalli banking specification first name. And I think I actually want to change that somehow, because I'd kind of like to make the distinction that the first name is not the name of the bank, but the name of the customer. So there needs to be some improvement, I think, there in terms of naming. But it's quite easy to see when you're actually like looking at the full names, like, well, is this name unique? Is it going to be unique through my application, and possibly even unique through like multiple applications, especially if this is going to be used as a library. So you want to be like as specific as possible with the naming, either in the actual name of the keyword or in the domain that it's in as well. So there could be a case where we have like a banking specification .customer, and then I put all these things under customer. But it's very flexible to do that, and it's very quick and simple to use that. I can just create another namespace, move all the specifications to that new namespace, and they automatically get updated with the new domain, as it were. I've used a regular expression for the email address, and we'll see later on this doesn't quite, it's not as easy to get a generator for this as it is for the other ones. So generating email addresses from this regex is something that's not built into the spec generators. But the rest of it is fairly simple. We've got some composite specifications, a simple composite specification here. In the UK, you can use either a house number or a house name. So when you're filling in a form to kind of register online, then normally you're passing in like the house name or number and a postcode, and then it will go off and look on some postcode service that's enough information to go and find your particular house. Postcodes are shared in the UK, so that postcode isn't a specific building. It might be several buildings in a particular area, but then the house name or number will then narrow down which of the small number of properties in this postcode you're actually referring to. And so I've made some of these, so we can use either a string here for the house name or number. We can either use a string predicate, or an integer predicate. I think there's also a natural number predicate, which I'd probably use here instead. And we're just giving these labels just to make sure that if this specification fails, then we kind of know which branch of the OR they've actually failed. So this adds information when we do like an explain on a value with a specification. It tells us where in more detail where things have failed. So that's quite useful. We don't need it for the AND because we expect both of those things to actually pass. And so then we can put all these small elements together into the residential address with some optional and some required. And then social security specification, we realize that there's multiple social security types out there. So there's a UK one, there's a USA one, there might be multiple ones, but as long as we've got one that fits into any of these, then we've got a valid social security ID. We can test it using conform and valid and explain as well. And so we can see when we explain something, if we pass in some information that's incorrect, it's going to go off and give us a lot of detail. And at first I found this a little bit overwhelming, but if you format it a little bit nicer, then it's a lot easier to read. You can see that things are actually where things are actually failing, and so it gives you a very much more information to very quickly fix the issue. And the issue in this case was it's just I was using unresolved keys, where I set it up as to, if I just add the map resolve, there's this map literals thing here, where we just basically specifying that if we put this hash : in front of it, then it will map on to all the keys in the map. So it's basically taken this expression and it's added the full namespace to each of the keys inside the map. So it's a nice, quick, simple way to do that. And if you just move this expression to a different namespace, then obviously it'll automatically update to that new namespace. And then we did things for the account holder. So we're basically the account holder specification is just the customer specification, but with this additional account ID, which is just a unique universal ID. And this is, so all we're doing is requiring, we could do it as a hierarchy, but I actually prefer to do this as a composition. So this would be the specification I would use. It keeps the map flat, whereas in this one we've got a nested map of customer details. So we'd have to do a little bit more work to process. If we have a collection of account holders, then having this just makes our algorithm to process a collection of account holders a bit more involved, where this is nice and simple to do, nice and flat. There's nothing wrong with this if there's a valid reason to have this. Sometimes you do want nested data structures as well, but if there's no reason, then just create them, keep them flat. So let's look at generative testing. Again, if you've got any questions about this, then feel free to add them into the chat. So this is, so now we kind of got our specifications. We want to put them back into the unit test namespace that we've been working on. So this is the unit test we were looking at. And so we already had Clojure test in there already. So we're adding this Clojure Spec alpha, so we can define our specs. and we're actually just going to include the banking specifications themselves. So then we can just refer to them by their full name, and it's very clear that we're using a specification and which one we're actually using. And, I haven't used an alias for this because I wanted to just use the fully qualified names of the specs that I was using. And we're going to use spec'd to actually do some generation of data. Right, so doing our generative data for generative testing. I just put this under spec'd, and it does see in my test it's although I'm not directly using this straight away, then so spec'd does there's something in spec'd, I think it's element that actually seems to rely on spec test, so I've had to include that as well to do that. And also the to get this to work for the testing, you do need to include that library as a dependency. So we do deps. With a big, oh, there we go, it's big. Oops. So here we've got Clojure test check, and I'm going to move this. So I put this as a dev alias, but I think having a specific spec check alias in hindsight, I think that's a better approach. Because that way you can very specifically include test check in a project, but then when you're actually shipping it, because we're just using these things as to test, then we can we can exclude that when we actually package up our application for deployment. We don't need to include the test check library in our running application, unless for some reason we decide to use test check in production as well. I mean, that's perfectly possible. It's not universally used, but there probably are some situations where running some checks in production might be quite useful. But again, you do need to kind of see if this has any impact on performance of your application and see if it creates any kind of bottlenecks. If you're doing some if you're doing a lot of streaming of data, pulling in data from there, then certainly using spec to check the data that's coming in is quite useful. Whether you actually want to run like test checks on things in production, I suppose you could use it as a very simple load testing exercise, but it's not as efficient and kind of robust as actually just doing some proper load testing. Let's go back. No questions? No. Yeah, so running the 3 Clojure Spec namespaces, I've got this is already there, so the actual banking on Clojure functions. So this is the functions that do the business logic for the bank. So just alias stem as software under test, and just including the specifications. So we can use generators to generate data. Unfortunately, when I tried to do that with the email address, then because I'm using a regular expression, it doesn't have anything out of the box. There's no spec I can pull out for that to make it actually work. So let's have a quick look at that. So if we go to so this is the project I'm going to push. I'll push this after I tied it up today. This is the actual project that goes along with this section of the book. So let's open the specifications. So I've got that in the banking specifications file, and so the email address I had was checking for if it's a string and if it's matches this this regular expression, which looks a bit scary if you don't usually do regular expressions, but it's not that difficult to pick through once you've got the basics. I did create a simpler version, but unfortunately this predicate function that I've created, this custom predicate version, is also does not generate a specification. But I kind of cheated initially because I just put it down to a string until I actually create a generator that can actually deal with specifications such as a regular expression. So there is a library I've made a note of that will cover this. But if they're fairly simple specifications, then it makes it a lot easier to actually generate, do some spec generation for these things, which I've put into the test. I hope. I was doing this a little bit late last night, so I think I've got it up to date. Oh, here we go. Yeah. So in the test file, we did have this mock data here. This is the original mock data that we had, and again, it was just hard coded, so that's not as flexible. It's not testing as much. So I did try and use this with the original email address specification, but generating a specification from this. So we basically go on and get a generator that's based on a particular specification that we've defined. So in this case, customer details. Here again, I'm using the full namespace. And then once we get that generator, then we can generate the values, or in this case, generate just generates a single value. So once I changed the so it was failing. So basically, what I did was just go in and do all the individual ones until I found out which one was actually not working. Let's make this a little bit smaller. There we go. So I took the customer mock data and just made generators. So this is like a halfway house. This is slightly better than just hard coding all the information, but it's not that great. I only did this just to figure out which of these spec generate expressions wasn't working. And then once I figured out his email address, and I didn't have time to kind of write a proper generator, unfortunately, last night. So I did just go back to using string, and then using string, I can just generate a new kind of value, and in this case I'm just putting on def mock, and so that way I can just refer to the result it's generating in customer def mock, and if I want to change that value, I'll just go re-evaluate the def expression. And so we get a value that is the kind of map that we're wanting. So it's generating in this case, it's generating a Practicalli banking specifications map, and so it's going to put this. So using the hash colon, it's effectively putting Practicalli banking specifications on in front of each of these unqualified keys to make them qualified. So that way it conforms to the specification. We can see it's generating like random values that conform to the spec. So email address is just a string, and residential address is a map inside there. So in this case, we are using a kind of a nested map because we're just basically hiding the residential address details inside a map, and that's also using qualified keys. And so it's a very easy way to actually do that. Because we can generate that information, then we can actually just go and use that inside our tests. So rather than using mock data here, I can go in and update this and just use the customer mock data that is the is the specification here. So we've got the custom mock data is now what we get from a generated value rather than like this hard-coded value that we had here before. And we can also use I don't have it here, I'll add this later on, but we can also add a validation to, we always use validation inside here, and use the valid spec valid function as a and as assertion to simplify this. So we'll have a look at that in a minute as well. With this question in the chat, I had issues coming up with the correct level of nesting, like where to put which piece of information in one map. Did think about writing specs beforehand to help in this design process. Yes, I think I would agree that writing specifications, whether you do it before or after kind of coming up with some data, it does help you refine the design. And so like specifications in a way is a bit like doing TDD. You want to sit back and have a think about, well, what do I actually want to express? So it gives you a chance to kind of do some design. So you're not just trying to like create a specification just to write some mock data. You're actually trying to help shape the design and put some thought into that design. And writing specs can actually help you with an awful lot with that, because you can then, as you start trying out those, generating data for those specifications, you can see the structure that it's actually going to be working with, the structure that your functions are going to be working with. And so it's a very useful design tool to use. So I think as soon as you actually start doing things, I mean, here we've been doing a test-driven development first, but we've incorporated specs really early on, basically when I'm doing my first specification. And so in future projects, I probably would just skip like creating mock data, or I might just do that and then instantly just create a specification instead, and then delete the mock data, and then I've got a specification that just generates that, and that would take a few minutes to like an hour, depending on how complicated the data model I was working with. But that kind of will be something I would do. I'd find value in doing early on in the development of an application. But even if you've already got an application going without any specs, then kind of retrofitting specifications as you're refactoring, as you're working and developing that application is very useful step as well. I think if you've already got an application, I'll go call it a legacy application. I think somebody said that everything in production is already a legacy application. But if you've got a system already, you don't need to actually go in and just spend like a whole week writing all the specifications for everything. I think it's like you see which aspects of that system you actually want to write a spec for, and you just do that. You just write a spec and see where you can actually use that spec, and see if you want to use any generative data from that spec as well. It might help you like refine some of the unit tests, but at least refine your REPL experiments as well. You've got data you can use in your REPL experiments, so you can call the function with a generator, and it will provide like different information that should satisfy the spec. So it's very easy for you to test the function in terms of the data it's getting, but also like in terms of the data it's returning as well. I hope that answered the question. Oh, there we go. This is to get back to the email issue, there is this test-chuck, which is a utility library for test check. It's got some nice generators that you can use out of the box, and the regex one is highly recommended for that as well. So that's something I can add to this section as well. It's like how to, instead of dumbing down my specification for email, I can use this library to keep a decent specification for the email address and still generate some data for that as well. So we've got spec data generate, so we can generate the customer details, and we can add that to our test. Oops, scroll it down. And there is, as well as generate, there's a couple other things. So there's generate, there's sample, which this is the example of sample. So generate will create a single result in the form of customer detail. Sample is going to generate 10 results in customer detail. And exercise for the data specifications, that will generate 10 results, but it'll also put those results into, it'll test those generated values against the spec. So it's also doing, it's doing generation, but it's also doing conform as well. I think that's quite useful, especially for the so like there's an exercise for function specifications as well. I think that's quite useful because it's then testing a bit more of the function itself as well. So I'll add an example around that. And yeah, here we go. So you could start to integrate as well as using kind of like the mock data, generated mock data in your tests. You can also use spec validate as an assertion inside here. So we've got an assertion which is. So like this is going to test if something is true or false. So rather than doing this rather clunky kind of are the keys all the same, but we have to put them in a set to actually make them the same, because keys generates a list and the lists is ordered. So when we compare two lists that are not have the same values but not in the same order, then it's going to fail. So we have to put that into a set. It just feels a little bit whereas you can just do something much simpler. You can just say, well, is the results that we're getting from calling register account holder with our mock data, is that returning some data that's matching the specification for account holder? And not only is that a lot cleaner, but it's also expressing the actual intent of what we actually want to do with this unit test. We want to see whether if we give some customer details to our account holder function, are we getting back a proper account holder? So rather than testing, rather than trying to kind of manually work out what all the different edge cases are and do some basic property testing, we're actually just using spec to do some generative testing and to cover a much wider base than we can probably think of ourselves as well, and in a lot less time and in a lot less code as well. So this is much simpler code to use. So this is a stepping stone into using a kind of full kind of test check thing. Again, this is just adding a little bit of spec into unit tests, so it's quite simple and it's not going to add any extra time because generating the customer mock data is pretty quick. And as if we put it into a def, then it's not going to regenerate it all the time, so it's going to be really fast to run this unit test. And just checking something against the specification is really fast as well, so we're not adding any delays to running our unit tests doing this way. And then we can start writing. So outside of our unit tests, if we're just developing something, especially when we're developing quite a lot of new stuff, then it's useful to put spec definition around there as well, because then when we're calling our functions as we're developing them, we can always make sure that we're calling them correctly and we're passing in the right data. So if we pass in here the very obvious bad data that we're passing into register account holder, then we're instantly going to get that feedback, and not just that it's failed, but why it's failed. Why has that function actually failed? And where should we start looking to kind of fix the problem as well? So we can see here, because we're passing in a key of bad, we don't have a bad key in our specification, and so therefore, I mean, it doesn't have any. We can't validate the type of the data against this the specification for bad because it's not there. And so we can see that it's giving us, this is the value that we've actually used, so we can see not that's just something that's failed, but why the information we've used to make it fail, and then all the individual problems as well. I've just formatted this a little bit to make it a little bit easier to read. But you can see that this is failing the first name spec and the last name spec. So all of the specs that are required for the customer detail map, the customer detail specification, and so if we just had one key that was not quite right, if we'd misspelt a key name, then it would just give us one of these, and we could very easily narrow down into what the issue was. And there we go. Let's see. Oh, yes. So I'm going to do some more. So I think doing the args and return values are quite straightforward for the function definition specification. I think there is the FN, the function specification part of the FDEF that it's still looking for more examples of how to use that as well. I think it's very easy to have a tendency just to basically re-implement your algorithm, especially if it's a simple algorithm, as the function. So I'm going to try and find some more examples of that. Where have we got? Yes. And so we can also instrument functions as well, which I think, yeah. So you can instrument a function. So we need to instrument the function. As a reminder, you need to instrument the function if you're going to, excuse me. You need to instrument the function if you're going to get it to catch when you're calling that function incorrectly. Oh, excuse me. And did we call it there? I've forgotten what it was now. Sorry. Yeah. So there's so instrument it, and then when we call it, then it's it will pick up and test the arguments that we're using to that function call are the same. Did I? Not sure if I added that yet, so I'll add that to the yeah, I'll add that to the code later on. Oh. Oh yeah, here we go. Yeah, so I've put these in the specifications for now as well, because that's where the FDEF is. And if I have, when I'm going to have multiple, if I have multiple functions that I want to specify, and I'll just define a name here of all the functions I want to instrument, and then just start them all up. Because one of the interesting things is while you're developing the code, and if you're changing the function specifications in the REPL, then you'll need to re-instrument the functions each time. Because as soon as you change the function and evaluate that new definition, then you're basically wiping out the instrumentation on that function. So what instrument does is basically takes the function definition and creates a wrapper around it, so it can actually do the tests for checking the arguments. And if you go and change that function definition and revalue it and put it into the REPL, then it's wiping out the wrapper that the instrument function created. So you have to run instrument again. So if you have a list of instruments, list of specs you want, a list of functions you want to instrument, then you can just basically just instrument all of those as a list, and then when you actually call it, so here we're calling register account holder, it's been instrumented. I'm using spec'd to generate some information in here as well. So this is going to generate a new value each time, and so I can very easily kind of evaluate this a dozen times and just make sure. It's a quick way to check to see whether this is if I've broken anything when I've refactored my function definition code. Oops, where do we go? I think we're nearly finished. Got the spec functions, and then and then we've got like testing, generative testing with check. So there's a Clojure Spec test alpha check function, and this is kind of the heavy duty generative testing function. So this is the one that takes time, and it's very simple. It's I guess it's a more advanced version of instrument, except it's also going to go away and generate all the tests for you and then run the tests. So basically generate all the test data and then run them against account holder and see what breaks. And it's going to be testing not just the return value, but if you're defining a function, if you're doing a relationship between the argument and the return function, it's going to test that as well. So by default, I'd use this as a more in the unit test or in system integration testing. I wouldn't just sit there. It'd be a bit frustrating if every time I evaluate something, I run test check, and I had to wait for like 80-90 seconds for it to finish. I would slow the development flow down a little bit, but you can change this. You can pass an option to the function and say, okay, I just want to run like 10 tests or 100 tests. Somewhere between those two values is pretty optimal, I think. 10 running 10 tests will be really quick. Should be pretty much instantaneous. That'll still give you a decent amount of coverage. 100 tests, I think you might just about notice the delay on 100 tests. It's pretty much will take about 1 or 2 seconds to do that. And so still it's very viable, and it gives you a lot more testing than you would normally do yourself manually creating some values to test on. And then you can also line up if you're going to run a whole bunch of test check functions on the specs, then you can kind of as well as setting the numbers to reduce the amount of time it takes, you can also do some summarize the results. So you can get like if you run like a lot of tests, you can just get at the end what the results were, how many tests you actually ran, and how many passed and failed. And so that's a very simple way to get a very basic test report. It's a bit like the unit test. It like tells you how many tests you've run and how many tests are passed or failed. It's the same thing, and it just adds that data to the end of the output of test check, because it's quite verbose. So that oh, excuse me, I'm gonna have to cough. So that kind of wraps up, I think, everything we've learnt about spec so far. Again, there's still some experimentation to do with generators, and I'll look at that library to help us find so test check to kind of go. I'll explore that and see what specifications we can use and how easy it is to write our own generators, and so we can keep our very detailed specifications without having to dumb them down. But yeah, that's covered everything. So it's covered the writing specifications for our data, writing specifications for our functions, organizing it, doing generative testing, integrating that with unit testing, and also some simple kind of spec projects as well. So while I'm not going to cover spec in detail by itself, what I'll do is I'll kind of, as I'm doing projects, I'll include specification in some of the projects I'm doing, and I'll add that back into this section as well. There's further examples of where I've actually used spec. I think that's probably the trickiest thing to know is to when to use it. So I think don't be afraid to use specs. They're quite simple, and they're not tied to the specs. Even if you create them, you don't have to use them. You don't have to run them. The way you actually make use of those specifications is very flexible, and it's something that's very useful to discuss as a team when you're working with other people, is to how best to use specs and generative testing in your application. All right, well, if there aren't any more questions, I'm going to leave it there, and thank you very much for joining. Again, there's if you want to reach out to me, feel free to reach out via Practicalli or any kind of, or even send me a direct message on Clojure and Slack as well if you don't want to ask a question in public. And I will leave it there. Start thinking about what else we can cover next. If you have any suggestions about what topics we want to cover, then feel free to do so. There's a whole bunch of content ideas for yeah, here we go. So 164 content ideas I've got. So there's a lot of stuff I'm going to be adding to the book, and some of that can be done through the learning through the study guides, because again, the study guides are an opportunity for me to learn things as much as hopefully the audience. So feel free to suggest ideas there as well. I'm also going to create some more formal videos as well, which are scripted, so they'll be very clear and have a very structured path. There's a few of those in the tools deps. I'm going to add those as well, so we've got a nice clear kind of foundation on how to install things and how to configure tools deps as well, which I did add. I've updated this section getting started, just to kind of show you like how very easy it is to get started with tools.deps and Clojure CLI tools. If you haven't done that already, if you're still using Lineon, that's fine. But if you want to try Clojure.deps, then this is a kind of nice guide that kind of walks you through all the different aspects of this. And I've also got this Practicalli Clojure. Where is it? Yeah, I've got this Practicalli Clojure repository of that's got all the aliases that you might want to use. So there's a whole long list of tools and additional aliases that you can actually use to make your Clojure developments even nicer. Even things like using the Rebel data browser that was from Datomic, and all sorts of different test runners and test frameworks, and lots of different kind of tools you can just plug in. You want to visualize the kind of dependencies between the libraries. There's some things there from there, and also like instructions on how to actually use these as well. So you can basically very easily create a visual graph of your dependencies as an SVG or a PNG file, and lots of other things in there as well. Some performance testing and benchmarking stuff. Okay, I'm going to leave it there. So again, thank you very much for joining, and hope to see you next time. Thank you. Goodbye.